Welcome to the University of Idaho, Utah State University, and South Dakota State University Sheep and Goat webinar series. Today, our speakers come from the University of Nevada, Reno. And so our first presentation is on drone assistant forage and rangeland monitoring. And our presenter will be Tracy Shane. She's a recent hire into the state livestock extension specialist position in the Department of Agriculture, Veterinary and Rangeland Science at the University of Nevada, Reno. Her research focuses on the use of cattle and sheep in prescription grazing projects and the integration of various technologies, including drones, GPS tags, and virtual fencing to support livestock production and improve management of rangeland ecosystems. She regularly plans and engages in education and outreach events, workshops, and events to foster producer-centered research and technology transfer.
Okay, great. Thank you. I really appreciate this opportunity to talk with producers across several different states here in the West. And let me know, Carmen, if anyone can't hear me, if you see any feedback that way. Okay?
Yep.
Okay, well, let's get started. I am going to cover a lot of new concepts, hopefully, for folks in the room today. I want to introduce the concept of our new extension programming we're calling the Drone Rangers. A little bit about the background and history on drones in range and pasture management, kind of highlight some of the technologies and things that people can use on farms and ranches and the large public land ranges that we have here in Nevada. Talk about some current limitations and future work and potential paths forward. I also will highlight some of our local folks here in Nevada who are building their drone businesses as well. So we started out as kind of just an educational and outreach group called the Drone Rangers. And then after I was hired into Extension, I have a blessing of being able to move forward and provide extension programming in the drone area. And to give you a little background, before we had drones doing rangeland pasture vegetation monitoring, people used to fly ultralights at very, very low, near stall speeds with high resolution cameras. And now people are doing it with drones, and it's a lot safer. To give you a little background, there's some different acronyms people use all the time in the drone space. They'll use things like UAV, talking about unmanned or uncrewed aerial vehicles, UAS being the aerial system, or small uncrewed aerial systems where they're talking about the drone, but also the sensors that the drone is carrying. And that's a big important part of how we look at pastures. This is a picture and an example of the kind of rangeland pastures we work on in large sections of Nevada. So drones are part of this kind of umbrella of precision agriculture and precision livestock farming. And if you haven't seen those definitions before, we don't always think about sheep and goats as being precision agriculture, precision livestock farming, but hopefully we'll change your minds a little bit today. So we gather, process, and analyze temporal, spatial, and individual plant and animal data in precision agriculture. And then precision livestock farming really refers to that monitoring of the animals and using other sensors to also monitor the grazing lands that they're on. Drone research is really new in terms of using drones for range and pasture grassland management. So you can see from this publication last year, the number of research publications that have come out has mostly happened between 2018 and 2024 in this area of how to use drones for monitoring these kinds of lands. This is an example of one of our drones here on the University of Nevada campus. This particular project was phenotyping sorghum for different types of processes, whether the sorghum was going to go into cereal grain production, go into forage or silage. And so they were doing a phenotyping project, and on this drone is a multispectral and thermal sensor for being able to evaluate the different phenotypes. So it's been, drones have been used in croplands, but we're going to talk more about the kind of pastures and areas that sheep and goats are typically on here in the Intermountain West. We can use drones to start measuring the different spectral reflectance that comes off different plants, and that helps us map different types of vegetation. And we have a lot of sagebrush, bitterbrush, and cheatgrass here in Nevada, and especially in the areas where sheep and goats, especially sheep, range on our public rangelands. And what you can see is depending on which sensor we have on the drone, such as the red edge, near infrared. These are two of the sensors that capture information in the non-visible range, things we can't see. We can start seeing that the spectral signatures of these plants are different, and so the drone can help us classify or describe which species are on the pasture. We can also look at greenness or different indices like the normalized difference vegetation index. And here's an example of a pasture that was flown with the drone, and even things that you might not pick out right away, you can see changes and differences in greenness and track plant vigor and vitality over time. Obviously, the planted fields are in the brightest green color, and the bare patches turn out a kind of red color in this particular example. Here's an example of some pretty high resolution pasture data. This is obviously land that is harvested. It's probably been planted to alfalfa or is going to go in back into production, but you can see the level of resolution to some extent and how large of an area that you can cover with the drones. And we can get really high pixel resolution, less than a centimeter per pixel, depending on how far we fly above the ground level. And that really comes in handy if we're trying to track invasive species that you're trying to get rid of, things that you want to spray, or if you want to quantify which plants are most important forage species and how much is available for setting your stocking rates. Here's an example of a rangeland pasture in Nevada that's been classified, and I apologize to anyone for the pukey colors. Like, it's very hard to show these complex plant communities in a screen, but what I've done is use the drone imagery and the structural information we get from the drone. We can pull out 3D point clouds to classify this sagebrush, bitterbrush, rangeland into different categories, and you can see some of the accuracy rates. Generally, I run in the 88 to 95% accuracy range in terms of being able to classify different parts of the rangeland or pasture into different categories of cover class. And this can be done on very small scale individual pastures, or it can be, drones can be used to really scale this to huge landscapes. So this, whoops, sorry, this is an example of how we try to do the scaling. Over here is a 1 square meter plot where we took a picture of all the cheatgrass and all the plants in the plot that we were going to clip. We clipped and weighed them to determine how much forage was available for a targeted grazing project. We mapped it on the drone data itself. And then if we have a sampling plan, these blue squares that are located in areas of low, moderate, and high levels of cheatgrass, we can start estimating how much forage is out there for us to do a fall targeted grazing project on dry cheatgrass. So you can see that our estimates were higher than they ended up being if we just used the clip data, we can't always control our sampling very well with our little plots. And so we were able to use that information and how much bare ground there was in some of these larger plots to then kind of bring our estimates more in line and set our stocking rates ahead of time more appropriately. Here's just some other examples of more grass dominated. There's obviously still a few little shrubs around here, but more grass dominated systems, vegetation cover mapping wise, and then we can also do vegetation height mapping, and that's what you see here on the right. And then just another example of different types of pastures. Again, this picture was taken when things aren't green, so sorry, it's in the fall, kind of around hunting season, but you can see that we can pick out the different shrub species very well with very high accuracy. We have a little harder time differentiating like forbs from cheatgrass and litter with the drone, but and even we were only 90% accurate on bare ground compared to litter and cheatgrass that can sometimes be very close in color to the bare ground. We've also done some testing, and when we estimate what the different cover classes are or compositions of the pasture are with this field cover measure here, we get a pretty high correlation with what our results are with the drone. And so that's a really handy option because the drone can cover more territory than we can while we're walking along doing transects. So we did apply a targeted grazing treatment. This particular example was with cattle, but I also have some sheep targeted grazing projects that I'm working on. And we were able to pick up slight differences in decreases or increases in cover classes with the drone data set that we weren't able to pick up with our field transects. So it has the potential of helping us notice things earlier in our grazing treatments or in our management options that we might not see if we do transects once every 3 years or something like that. Another way some people are starting to use drones, this is from some data I collected maybe 5 years ago, but we can difference the heights before and after grazing and start to look at maybe which areas of the pasture the sheep are spending more time than others, or maybe where goats are more effective at removing shrubs and things like that. I'm going to watch my time close, but to really blow everyone's mind, there's some robotics professors here at the University of Nevada, Reno, who are also working on using light detection and ranging and really, really high resolution RGB cameras to do instantaneous real-time classification of the plant species in the pasture while they're flying the drone. So they've got the drone feeding back information immediately while they're flying back to their laptop. And you can see in the lower left corner is the fisheye view of the drone flying. This is a canopy height model that the drone is building using the 3D structure that the LiDAR unit it's carrying is feeding back to the computer. And then it has that high resolution RGB camera, and it can do real-time classification using computer vision and a convoluted neural network to classify things into sagebrush, cheatgrass, and so forth while it's flying. This is very experimental. I don't expect that this is going to be on the market for producers to hire this out and get this level of data anytime really soon. But whoops, let me go back to this one. But in the next 5 years, I do expect that we'll see some of these products and services available to farmers and ranchers. What you're seeing here is one of my students that's worked for me. He has a spray drone. And what you might have caught at the beginning of the video is there's some dark, large plants in the background. Those are Scotch thistle. And he's been using his spray drone to go out and not only scout for Scotch thistle over large areas. They run on probably over 100,000 acres. And so he scouts for the Scotch thistle and then fills the tank and sprays the Scotch thistle uh, using just a spot spray mechanism instead of having to fly the whole pasture using an airplane. The cost on spray drones has really come down over the last couple of years, and it's starting to become quite competitive with running ground sprayers. And the way that they're able to do this locally here in Nevada is because they can target only the plants that are the target plants for removal. They can reduce the amount of product that is being used. They can, similar to using aerial applications with airplanes, they can apply the spray at the time of year that works best for the target plant rather than waiting for the ground to dry out. A lot of the farmers that are using these services right now are excited to no longer be getting stuck out in the field trying to pull a spray rig out when it's a little too wet to be doing so. They can also usually reduce the amount of overspray compared to using traditional methods. The only limitation that we're seeing is these drones can only carry so much product. So if you're putting on more than 6 gallons of product per acre, the cost benefit ratio starts to fall apart. So as long as your application rate is much less than that, then and the number of acres can fit within the number of batteries that the owner operator has for the drone, then the cost per acre can be pretty similar to ground sprayers, about $1 to $2 more per acre at the moment. So some of the folks that we have here in Nevada that are taking off and running with their spray drone businesses, some of their quotes, Ian Spratling here, he says, before drones, we used to get a lot of drift from the airplane. It would kill the willows in our pastures. Now with spot spraying by drone, we've increased the biodiversity in our meadows. The willows are doing better and we have greater forb species diversity. So for them, it's really improved their management on their private lands, and they're starting to get a lot of attention from their public land managers that are adjacent to their private land pastures. Wyatt Ghetto is in Fallon, Nevada. He owns Desert Oasis Spray Services, and he says that he gets a lot of shock and awe because these spray drones are really big. They can pick up a person who weighs 250 pounds. They're that big. And so he says that he runs into a lot of farmers that are really shocked at first, but then often say, you know, if only my dad or grandpa could have seen this. And he's seen that even a lot of the older farmers he works with are excited about where the technology is going, and they see it as a big part of keeping small farms alive in our area. And I'll give you a little example of Wyatt.
Can't hear it.
Okay, thanks for letting me know. I'm going to skip Wyatt's explanation there, but he's essentially telling everyone that the main limitation for him with such a large spray drone is that the batteries do only last about 15 minutes, sometimes 20, and then he has to swap out other batteries. So currently, the number of acres that can be sprayed or treated with a fertilizer or any other type of aerial application product is a little bit limited at the moment with batteries, but we've seen really great improvements in technology. And some drones even use gas or hydrogen or other fuel sources on board to help extend the distance in which they can travel and apply product. So what are some of the other limitations besides battery life? The startup costs can be pretty high. For a scouting drone, you would expect at least a really high quality one anyway, at least $4,000 to $8,000. You can get little mini drones from DJI at a lower price point, but they're a little, you wouldn't start a business with those as much, just because it's harder to fly the same field the same way year after year, to determine the efficacy of your management. There's a short half-life on the number of years that the technology stays on the market. It's kind of like when you buy a computer, it's out of date almost immediately because there's already the bigger, better, faster computer that comes out. And so we have that problem with drones a little bit. There are some regulatory concerns about using foreign made drones, especially DJI being a Chinese drone company gets a lot of concern. And that's something to consider because depending on how and when and where you're using their products, you could be feeding data straight to China. There are things you can do to prevent that. But there's also a lot of need for infrastructure for processing and storing the data. You have to have very large hard drives, external hard drives for saving that data, and some pretty fast computers for processing it. So those are some of the limitations that can sometimes make it difficult for people to jump into this space and add it to their way of tracking how they're doing on their range and pasture management. So how do I see this playing out in the future? Really, I would love to see agricultural cooperatives, conservation districts, weed districts, working with farm and crop advisors to form groups and or have conservation districts be the ones that put in the grants for owning the drones and then hire the pilot that goes and flies for everyone in the valley. I think that would be the most cost-effective solution for a lot of agricultural producers to have a certified pilot that their conservation district deals with all of that aspect of it, the regulatory aspect of it. And then folks like myself work with those conservation districts and the farmers and ranchers to provide data analysis, interpretation, and help explain how this technology works and and kind of get the feedback from farmers and ranchers too on what else they want to see it be able to do for them. And then from that kind of process, eventually get to more formalized drone monitoring protocols for being able to track your trends over time on the success of your pasture management and eventually create some really super user-friendly, actionable reports that would make sense to a farmer and rancher in terms of their grazing management plans. So to finish up, drones are going to help us manage for resilient pastures and rangelands. We have incredible new technologies like machine learning and computer vision that are really going to help us spot problem weeds or even changes in the pasture that the livestock producer can respond to. But there's still some big questions out there. One of those is who's going to own and manage all of these data, like the thousands and thousands of images that the drone takes. And I really wonder if farmers and ranchers will lead this revolution or if the tech sector is going to push it onto farmers and ranchers or push it towards regulators. I would like to see farmers and ranchers and young people getting more involved in their own data sovereignty and collecting this information themselves. So that's my soapbox for today. I would love to take any questions and address any concerns. This is maybe a new topic area.
Thank you, Tracy. That was really good and very informative. We did have one question come in and we have about 4 minutes until we're gonna have Andrew start. So I'll ask this question and you have a couple minutes to kind of answer it. So
Okay.
the question is from Michael Wilk. I own a 56 acre grazing operation in the Northeast. Wondering if this technology makes sense financially for a small farm such as mine. I imagine the answer is it depends, but any insight would be welcome.
Right. I think it really does depend, Michael. I have a kind of a smaller sized producer for Nevada who also owns a construction company. So for him, it was a no-brainer. He's like, I'm going to fly the drone over my construction sites and apply all my validation for the work they're doing on their construction, but he's also going to be using it on managing about a 200-acre pasture. And he also has a lot of weeds that he's dealing with, lots of different things for him to treat. So financially, that price point was there for him. I think it's going to take a little while, especially with American-made drones, to get to a price point for small farmers and ranchers. And that's why I'm pushing towards working with conservation districts where like an entire valley or agricultural area could benefit from a single drone. Does that make sense?
He probably can't call or talk in, but it makes
Right.
sense to me, and I think that's a really good use and a good way for people to learn about drones is if as a region, a small area, they could work together to have a drone and all benefit from the data.
Yep. And I think we just need to develop good safeguards so everyone knows that their data is not going to be shared with their neighbor and things like that. It is important that livestock producers know, though, that there's currently not very many regulations preventing environmental groups or anyone who wants to fly over your farm or ranch from doing so. So that's also something that farm bureaus and agricultural groups may want to address in terms of their own data sovereignty, because uh, yeah, currently the airspace is the airspace, and just because you own the land doesn't mean you own the airspace. And there's a lot of states prohibit you from taking down drones over your own private property. So,
Got it. That's
yeah.
very good to know. So we had one more question. We have a couple minutes, so we'll answer it real quick and then we'll start with Andrew. They asked, have you done research analysis on the ROI of use of drones versus no drones on actual pasture improvement?
Sorry, the ROI of spray drones versus like traditional spray equipment.
It says use of drones versus no drones. So,
Oh, okay. What's the return on investment?
mhm.
Yeah, I think it's really going to vary from place to place on the timing, especially for spray drones, the timing of when your plant needs to get sprayed for the greatest efficacy of that chemical. What we run into in Nevada, even though we rarely have water, we are an irrigation-based system here, and so frequently we need the soil to be pretty moist for the efficacy on that chemical application. And that can prevent in some of our really glade clay soils from being able to get out there with the equipment at the time that we really need it to be out there. And so in those situations, the return on investment is really, really good. In terms of pasture management, that doesn't involve spraying drones and you just want to track changes over time. I think that in the next 5 years, we're going to see consultants and folks that crop advisors, people who might help you, that you might hire to do that. If that's not your bailiwick, I could see their price point coming down to what they would charge you, whether they used a drone or not. So I've actually been consulting with a lot of companies. They'll call me and ask how they can start using drones to help reduce the cost for their farmers and ranchers that are their clients. So we're working on it.